All right, the micron gauge. As you can see, it's about come to a steady state right now. It's been steady for about 1 hour right now, and it's at 2200 microns. This has been on the vacuum pump, what was it, since 4 o'clock yesterday, and it's almost 8 o'clock now. And the last hour it's been turned off and separated because I want to see the vacuum decay. Still tons of moisture in the system. There was a failed... Okay, so what happened was the valve core broke off inside of here. Let me see if I can zoom in on this. Come on, zoom in. Okay, well, you can't see it. But inside this fitting right here, half of the valve core is still stuck around. Only the center came out, and I couldn't get it out. So I had to pull out, and I plugged it right there. That was there. I was going to get a new one. I went down to the hardware store, but what I didn't look inside. They don't have the threaded portion in there. So I ended up putting a cap in there instead. And so you go, well, how do you remove that last moisture? Okay, so what we're down to is what's called molecular flow. There's no substance, there's no matter other than the moisture that's trapped in the pores of the metal comes to the surface, but it doesn't move through just a vacuum of alone. So what I need to do is sweep this with nitrogen now to get this lower. It won't go any lower. I could put vacuum pump on here for the next week and it'll go a little lower, but that would be a long time. So what you do is you get a heat gun or any heating method. You heat up the whole tank. Get the tank to about 120 degrees, 170 degrees, whatever you can do really fast. Get the tank hot. And what this will do under vacuum is release more moisture at the molecular level out of the pores of the metal, and they'll come to the surface area, but they'll just stay there. Even though you have the vacuum pump on, they won't come out. Very few of them. Some will come out, but they'll stay on the bottom of the tank over the whole surface. Then you introduce, like say through, well, I took off the other fitting, no, this fitting. So you introduce nitrogen inside the tank, and what the dry nitrogen will do, it will disturb and it'll sweep the moisture molecules that are just hovering over the surface of the metal, and it'll stir them up and mix them into the dry nitrogen. So now there's a mass volume of nitrogen filling the tank back up to 0 psi. Then you turn the vacuum pump back on and you pull the vacuum out fast. And what that will do is the moisture molecules that are now floating and suspended in the nitrogen will come out with your vacuum. It'll pull them out. And the next time you draw a deep vacuum, more moisture will come out of the pores of the metal to the surface. And you'll start getting down from that laminar flow where you're taking out a massive volume of nitrogen that has moisture molecules in it. You'll get down to the molecular level where the molecules coming out of the surface of the metal will no longer travel to the exit. So then you repeat that process, and the hotter you make the tank, don't damage anything, the hotter you make the tank and the more flow is just like a glass of water. You have some chocolate milk in it and it's dirty, you pour it out, the glass is dirty. Put some water in it, swirl it around. Well, you can see through it, it's kind of opaque, but the glass is still dirty, right? So what do? You pour it out. That's your vacuum. But you can still see the rim of chocolate in there, and you can still see some cloudy water pouring down the sides of your empty glass. Pour some more fresh water in it, swirl it around again and look at it. It's almost clear, but you could see a little bit of cloudiness. Now pour that water out again. That's like the nitrogen again, another nitrogen. And you repeat that process. Is the exact same of heating the tank and putting nitrogen in and then vacuuming it out. You keep diluting down the ratio of moisture molecules in there, and you rapidly move them instead of relying just on vacuum alone at room temperature. See you guys later.